northwestern boundary of yeah. I've chosen the topic related to the northwestern front of the Eastern Ghats Mobile Belt. So this part of the mobile belt, is very critical in the sense it is not like the northern boundary or the southwestern boundary, where you have an additional front like a Rengali front or Jaipur front or Krishna province front. Here the front is very clean. The front is very clean in the sense it is directly in touch with the craton, established craton. There is no doubt about its edge. The Bastar craton is well established, its edges are well established, and the lithology also well established. So Eastern Ghat is directly in touch with the Bastar craton in this part of the mobile belt. So Rudra, I have to go to the second. So this is the map, all of you are acquainted with. Ramakrishna Natal, 1998. Dr. Nanda is also part of this preparation of this map. This is a very excellent map, Just like Heron has prepared his map of Aravali, this is an excellent map, and the report written over this map, though it is very short, but it is very much informative. So I have chosen the bulging part of the Eastern Ghat Mobile Belt. This part, I think you are able to show my pointer. So this part, if you can see, it appears as if it has gone from the normal trend of the Eastern Ghats over the Bastar craton. So this is the part which have fascinated me a lot, and I have chosen this part, for my research work. So we have published several papers on these areas, and 3 to 4 PhD students have also got their doctorate. So I have understood to a certain extent, so that I am going to share. Now, overall geology, all of you know, so I need not have to discuss those things, If you come to little south, which you say Jaipur province, we have a transition zone and the western Charnopite zone, which is not present in this part, this bulging part. This bulging part, I have given the nomenclature that it is a salient of a thrust belt. The entire western part I have discussed or interpreted as a thrust, and this bulging part is a salient of that thrust belt, and this which is coming towards east is a recess part, salient and recess structures. These are the overall structure of this belt. Now I'll go to little detailed map. This is a very generalized map. Now this is the front. This is the front. To the west, Bastar craton, and to the east, the Eastern Ghats. So Eastern Ghats, as you know, these are all granulite facies rocks. Now, if you go to the northward, there is a change in the trend of Eastern Ghats. It has become almost east-west. And gradually, if you go further east, it will meet with like this, It will go to Rengali province. The northern boundary of Eastern Ghat belt will meet this part. And if you come to south, there is another band here, which is coinciding with Nagavali Vansadhara shear zone. These two boundaries, northern boundary and southern boundaries, I have interpreted them to be as Paikmal lateral ram, and the southern one is Khariar lateral ram. So this is a thrust belt, and the central part is a salient, and the north and south have two strike slip faults in form of lateral ramps. So the frontal part is a frontal ramp, you can say. Now this part is very fascinating in the sense, I think this is the only place where you will find the shear zone, which is demarcating the boundary between craton and the mobile belt, is so well developed. Nearly 2 to 3 kilometer wide belt of protomyelonite, followed by myelonite, ultramyelonite, the typical juxtaposition of the myelonites in this belt, and ultimately the eastern part, the protomyelonite and myelonite part of that zone is developed in the Eastern Ghats. So Eastern Ghat part is also sheared, and the Cratonic part is also sheared. So together, they form this shear zone or the thrust. So this thrust is not purely a granitic thrust; it is also partly granulitic thrust. So the grade of metamorphism will be amphibolite facies grade. So the Eastern Ghat granulites has been retrograded to amphibolites, and the granites in the Bastar pattern, they have been also deformed to a myelonite and a biotite, and some amphiboles have developed. So overall, it is a amphibolite grade shear zone, and to the west, the granite which is lying here, it is a undeformed granite. There is no deformation fabric in this granite. It is massive and equigranular with potash feldspar phenocrysts, abundant potash feldspar phenocrysts. They are occurring here. So this type of setting, a well-developed shear zone affecting both granite and the Eastern Ghats, and undeformed granites. Undeformed granite in this sense, the parent granite is not deformed much. It's just like, Dharwar batholith, that sort of granite, 2,500 million year granite. So they are occurring close to the shear zone. So that means it is an undeformed granite which has been sheared. That is why the myelonitic structures are so well preserved. But if you come towards south, south of Bodan, Sinapali, Bodan, those areas, this type of undeformed granite, 2.5 billion year granite are not there. So granites here are all 3.5, 3.7 billion year tonalite, trondhjemite granodiorites. They have very well developed gneissic structures. So over that, when this thrust is developed, they are mingled. You cannot clearly demarcate the thrust there, which you can do very well in the central part. That is why the thrust zone to the south, Dharamgarh and Sinapali areas, not well marked. So there, this transition zone things comes into picture. But this part, no transition zone, because directly the granite is in direct contact with the Eastern Ghats. Okay, so this is the setting, and I'll show you one more map. So this is a detailed map of Lakhna area. Now you can see the eastern part is Eastern Ghat Mobile Belt, this light green color in which there are some charnokite bodies, charnokites. Now this yellow color is the shear zone or the thrust. You can see the strike deep. They are northeast, southeast striking, myelonitic foliation with the down deep, stretching lineation. Now if you come to further west, the 2.5 billion year granite is existing. Now this granite, you see this part, particularly the Lakhna part, there is intrusion of several dikes. So those dikes are mostly north-south, but there are also east-west, northwest, southeast trending dikes. Now these dikes vary in composition. Vary in composition means they have dolerite, they have basalt dikes, rhyolite dikes, cyanide dikes, trachyte dikes, varied compositions, gabbroic dikes. So these dikes, they are occurring very close to the shear zone. One of the dikes, you can see they occur in the within the thrust and have been deformed and folded because of the shearing or thrusting. The dike has been folded and sheared, and I am having still doubt. This dike might be continuing into Eastern Ghats also. This might be continuing into Eastern Ghats. Somehow I could not trace that part. Probably one can trace this dike into the Eastern Ghats, but I have not done that. Other dikes are very close to the contact. They are mostly confined to the craton. Now these dikes we will now discuss. Now, as you come towards west, the granite is overlain by this platform sequence of rocks. This platform sequence of rocks are called Khariar Basin rocks. So there are isolated remnants, isolated remnants because of the erosion. They have been left out, but the major part is here. That is the Khariar Basin where this quartzite plus shale, those sequence are horizontal sequence of those rocks are existing. Now, these rocks, this platform sequence of rocks, at places, they have very clear cut conglomeratic base, suggesting that a prolonged weathering and erosion has formed basins over this Tectonic rock, in which these rocks are deposited. So this is how these basins have formed. Now we will discuss these three units. One is your Eastern Ghats and shear zone. Then we will discuss these dikes. Then we will discuss this Purana rocks or the platform sequence of rocks, and what is their tectonic significance. So my study area is this much only, and little south towards Sinapoli. Now let us come to the next one. So here I have, these are very old publications. 2007 we have published these papers, and recently also this 2019 or 20 we have published the papers in ESS. This shows the myelonites and their kinematics. Now you can observe, the northwesterly versions of the myelonites. The Eastern Ghats has been thrusted up over the Bastar Craton. So this is a SC fabric. This is a porphyroclast, tailed mantle or tailed porphyroclast. This is a rotated porphyroclast. Then this one SC fabrics. So these are the stretching lineations. These are rotated porphyroclasts. This is also a rotated porphyroclast. So all these things clearly says that the Eastern Ghat rocks have been thrusted over the Bastar Craton. It is a absolute, there is no oblique thrusting, or it is absolutely right angle thrustings. Very rarely you will get a oblique lineation. They are mostly down deep lineations. And the thrust, the shear zone will be somewhere around 45 to 60 degree deep, 45 to 60 degree deep, and very well foliated. And a part of the Eastern Ghat is also well foliated and retrograded. So this is how this shear zone is defined there, or the thrust is defined there. Now, if you come little south, if you come little south to Sinapoli area. Now here you can see the Sinapoli area. So there are many things in Sinapoli area. So here I have defined, there is a nepheline cyanide body. This blue color one is a nepheline cyanide body, which is occurring within that thrust, within that shear zone. Apart from that, there are many mafic granulites, and acid sarlochites. Those rocks are there. And if you go to Dharamgad part, there is a large outcrop of the Bastar Cratonic rocks, the granite gneisses, which I have named as Dharamgad window. Now this is Dharamgad window, and these are the Sinapoli group of rocks, or I have named as Sinapoli Nape. And if you come towards Khariar, then I have identified this Khariar lateral ramp, then Lathur Nape and Turikala Nape. So the salient structure consists of several napes: Sinapoli Nape, Lathur Nape, and Turikala Nape. So all those napes has been over thrusted the Bastar Craton. And this thrust belt has a tectonic inlet or the window, which we have termed as Dharamgad window. So this is absolutely a very flat land having the granite gneisses or the tonalite, tronzomite, granodiorite gneisses. So we have discussed three such napes in this salient structure. Now the important part came here is this cyanite rocks, which was not there near Lakna or the other part, northern part. The cyanite was not there. So this rock is very interesting, very interesting. Now I will come to the next part. Here I have shown how the different napes, they are existing over the thrust. So this is the sole thrust, which I have named as terrain boundary shear zone. Over that, the Lathur nape is existing, then Turikala clippage is existing. Like this, the whole salient consists of a stack of napes. Then if you come towards south, this is Dharamgad window. And this is a north-south cross section how those ramps have been constructed, that I have shown. The Khariar lateral ramp and if you go to further north, Paikamal ramp will come. So that is how the salient is defined. Now, I was talking about this nepheline cyanide rock. This nepheline cyanide has been studied by many workers. Many workers they have studied and they have determined its age, they have determined its isotopic compositions. Several things has been told. So it is nothing new to the area or nothing new to the world. But when I saw this rock, I found it is extremely deformed. You can see the folds, extremely deformed, isoclinally folded rocks. Open folds are there. When we saw the thin sections, and they are also very much sheared, with stretching lineations almost conforming with the surrounding thrust. Down deep stretching lineations are existing over the cyanitic foliation. When we saw the thin sections, we found a great variation. Great variation in the sense, the core part of the nepheline cyanide has a structure like D. See, individual crystals are aligned parallel to that foliation plane. So we defined this one as a magmatic foliation. Magmatic foliation, and if you see the D, it has a metamorphic foliation or a deformed foliation, tectonic foliation. So this tectonic foliation and this magmatic foliation, they are parallel. So we thought probably this nepheline cyanide has intruded this shear zone, during shearing, during thrusting. That is what we developed this idea that this is a synkinematic emplacement. This is during thrusting, this has come. So we thought if you date this rock, then it will tell us the age of thrusting. That is what our belief was. So, and you see the individual feldspar crystals, they are still maintaining the rectangular margin, rectangular shape. But same time, there are some feldspar crystals or nepheline crystals, they are having some very curved margins, oblate margins. So both things are existing. The magmatic fabric as well as the tectonic fabric, both are existing together. That is the reason we thought this is a synkinematic emplacement, a synkinematic intrusion. Okay. Then we determine the age of this nepheline cyanide. So nepheline cyanide, almost right from Khariar to, there is a place called Karangamal, Babebir. We collected many samples. Out of that, we selected some 5-6 samples and dated them. So our dating was done in Australia. So one of my PhD students, he separated zircon here in IIT Bombay. We have a mineral separation lab. After separating the zircon, we send it to Australia. So we have a collaborator there, BOT. So he determined, he took the photographs, then did the shrimp dating there. So what he reported, the ages are very young. The ages are coming 552 plus minus 10 million years. 552. Then 541. Then 513. Invariably, they are 500 plus minus ages. All 4 or 5 samples, they produced these results. So, but there are reports, from the same area, from Khariar area, that these cyanides or nepheline cyanides, they're older. 1.3 billion year, 1.4 billion year, 1.2 billion year, nepheline cyanides are there. But what to do? We found, and we did all these things in the shrimp machine. So there is no doubt about the dating methods and other things. And moreover, the lab, the BOT used, it's a well-established lab in the world. So we published these papers telling that the thrusting has taken place around 514 million years. That means it is a pan-African thrusting event, solely based on the dating of this nepheline cyanide rock. And our field observation was the nepheline cyanide intrusion is synkinematic to thrusting. We found the magmatic fabric and the tectonic fabric to be parallel. That is our basis of telling them to be synkinematic, and the age came invariably. All of them produced similar ages. That is the main thing. Nothing, not a single one produced 1.2 or 1.3 or 1.4. It didn't go to that range. All of them came like this. But later on, people are dating, they say Now we are getting 1.4, 1.3 million years of these nepheline cyanides. So what is great about it? There may be two stages of, as Mr. Nanda has reported, there may be different stages of alkaline intrusions. But I will give you some more explanation to that. I will give you some more explanation to that. If you see the nepheline cyanides occurring in Bardangwa, northern march, or Kamakhya Nagar, sometimes I hold discussions with Mr. Nanda or P.K. Pandasa. So they said that those nepheline cyanides are 1.4, 1.3 billion year old. Could be 1.3, 1.4 billion year old. But so far as this study is concerned, we are finding 500. So definitely there are two stages of nepheline cyanide intrusions, or the alkali cyanide intrusions. But my further study will tell you some clue to this. That is what the main point of this Northwestern round. Okay. So ours is 517 or 540 million. Now, what happened? I'll just show that. These are the dikes. These are the dikes. I told you near Lakhna there are, which we have named as Lakhna dike swarm. So there are several dikes there, north-south dikes and east-west dikes. Those dikes we analyzed. We did the RE, we did the trace elements, but here I am just giving one major element diagram, task diagram, where the dike shows a varied composition. Rhyolite, starting from rhyolite to basalt to tephrophonolite, trachyandesites, trachytes. There are some beautiful trachyte dikes there. You can see the flow texture. The alkali feldspar grains, they are just straight, they are occurring absolutely undeformed. And they are occurring very straight in the direction of the dike. And if you see the thin sections, those feldspar crystals, they will be bending around the feldspar phenocrysts. So this is very beautiful looking trachyte dike in Lakhna area. So that means these dikes do not belong to a single clan or single class. It is a wide range of compositions, right? From rhyolite to the phonolite, undersaturated to oversaturated dikes are there. So these dikes can give a clue to that why nepheline cyanides are giving two different ages. Nepheline cyanides are giving 500 something and 1.4 something. So why these two ages are there? And see, many review papers I have seen, they say whatever Biswal has done, maybe a altered nepheline cyanide. Like this, some comments have come, but there are two different generations of nepheline cyanide dikes. So if those gentlemen would have studied these dikes, the Lakhna dike swarms, probably they would have got the answer. Now, those dikes. So one of my collaborators, in Australia, he came to study these dikes. He's a geophysicist. So he wanted to do some paleomagnetic study. So he analyzed these rocks in his laboratory in Australia. So he found most of the dikes are highly differentiated. You can see the curves, highly differentiated. And we explained that these are all related to the subduction zone. Subduction zone magmatism. They are not related to, though we have written their extensional setting derived. Extension can also occur in a subduction zone, but they are not rift related dikes. In a rift setting also this type of dikes can come, but this trace element and RE study do not support its rift setting origin. Rather, it supports a subduction zone setting origin. So from an enriched mantle below a subduction zone, so this type of dikes have come. So you must be knowing, the subduction zones are the place where calc-alkaline rocks, alkaline rocks, they are, that sort of volcanism takes place. So probably it is the result of the subduction zone volcanisms. So this is the result of our trace element study. So this is the picture. So that means the Eastern Ghats is subducting under the Bastar pattern, and this is the magmatism that is taking place. So here that 1.4 dikes are coming up. So these dikes has a undersaturated variety. Phonolite, trachyte variety is there. So there could be some dikes which is nepheline cyanide also. We have not seen that. Or they might have eroded away. So in the subduction zone, those 1.4 billion year dikes are emplaced. That is what its geochemistry says. So if you imagine that Eastern Ghat Basin is subducting under Bastar Craton, and this intrusion is taking place. So that means these dikes will tell you when this deformation or the Eastern Ghat orogeny took place. So it is a 1.4 billion year orogeny. Now during 1.4 billion year orogeny, Eastern Ghat deformation took place. This part of the belt I am talking. Now some of these dikes could occur very close to Eastern Ghats, within Eastern Ghats also. So those, some of them could be alkaline, like nepheline cyanide, some of them could be alkaline, and they will be deformed and metamorphosed. Like, you know, northern margin of the Eastern Ghats. So we have 1.4, 1.3 billion year nepheline cyanides. They may be part of this volcanism. When Eastern Ghat orogeny was taking place, they came up. So now they are disposed of in the northern margin, and some of them are along the western margin. So this is a phase when Eastern Ghats main orogeny has taken place. 1.4 billion year orogeny. Now you must be knowing that Eastern Ghat orogeny has undergone several orogenic phases. 1.4 is there. 1.4 people related to Columbia supercontinent cycle. Then 1 billion year orogeny, 0.9, 0.95. That those edges are come for Charnokites. So the people related to Rodinia supercontinent cycle or the Greenvillian orogeny. Now there are also 500 billion year edges are there, particularly in the northern margin, western margin. Our nepheline cyanide, the nepheline cyanide which we have studied, they are 500 million year. So that means the Pan-African orogeny also is there. So we have now three definite orogenic cycles has affected the Eastern Ghats. Columbia, you see in the metamorphism, deformation of the Eastern Ghats, and these alkali cyanide intrusions or the rhyolite dikes intrusions, basaltic dike intrusions, they are all evidences of that Nuna orogeny, which gave rise to Columbia supercontinent. Then 1 billion year Charnokite metamorphism, granulite metamorphism, several part of the belt, like northern part, central part. So they are Greenvillian orogeny. Then the alkaline intrusions, particularly Ferrier area, 500 million year orogeny. So three orogenies are juxtaposed this part of the Eastern Ghats. And 1.4 billion year orogeny is well entrenched in this part. The nepheline cyanides we are talking about, it is showing 1.4 billion year, and I am getting 500 billion year. What's great about it? One might be belonging to Columbia, another might be belonging to Gondwana land. So there are two different orogenies. So they are coexisting. And now if you want to date a orogenic phase, then this is important. If you want to date a thrusting phase, then the nepheline cyanide which we have dated, that is important. So these two events has to be kept separate. They are two different events. So two different events has produced these things. So that means the Lakhna dike swarm provides an evidence of so many nepheline cyanide dikes which we are getting along the margin belonging to 1.4. So these are part of this magmatism only. If you read some of the papers from the northern margin, the nepheline cyanide, they are included inside the granodiferous, the charnokites of the or the granulites of the Eastern Ghats. Both sides we have granulites, and in between you have Kamachanagar nepheline cyanides, then Bordangwa nepheline cyanides. Both sides you have granulites, And those granulates show metamorphism belonging to 1.4 billion year. And nepheline cyanide is also deformed and show age of 1.3, 1.4 billion year. So that means during Eastern Ghat orogeny, they have come up. The same thing also this dike is telling. So dike is the evidence for this Eastern Ghats, the main orogeny, 1.4 billion year orogeny, that produced these nepheline cyanides all along the margin, and as well as this Lakhna dike swarms. So that's what I was telling. This dike swarm will tell you what are those two types of nepheline cyanides in the northwestern front or the northern front. Okay. Now, those nepheline cyanide or the dikes, Lakhna dike swarms, we have dated, and you see invariably they are producing the edges of 1.4. This is also 1.4. This is also 1.4. All those dikes are 1.4. That matches with our nepheline cyanides. Now, this dikes has some xenoliths, which are showing edges like 2.6. Then one more edge is 2.5. So these edges are the xenolithic edges or xenocristic edges. So those are picked up from the Bastar craton. So Bastar craton means those granites which are occurring close to the Eastern Ghats. So it shows those things. And one more edge, 3.7, would be the oldest in Bastar craton. It is a xenocristic edge. So that means this dike, while coming up, it is picked up those cratonic zircons, and they are showing these older edges. So 1.4 billion year magmatic event or volcanic events within this the cratonic area clearly marks the collisional orogeny or the Eastern Ghat orogeny that took place during Columbia supercontinent, which we say as a Nuna orogeny. So this is a part of Nuna orogeny, whether it is the Lakhna dike swarm or your nepheline cyanides in the northern margin or the western margin. But during Pan-African orogeny, we have got another phase of nepheline cyanides, that is 517 million years. So, well, the Western Ghat is a perfect example of multiple orogenic cycle. Nuna, Greenvillian plus Pan-African. All three orogenies are imprinted over it. Similarly, those who are acquainted with the Aravali, it is also there. The Aravali orogenic cycle, Delhi orogenic cycle. It is well spread out from Columbia to Greenvillian to Pan-African. So most of our proterozoic mobile belts, right from Aravali Delhi to central India to Singhbum, there is clear-cut evidences of multiple origins. Nuna, Greenvillian, and Pan-African. The point is we have to identify the features. We should have sophisticated laboratory to date those rocks. Otherwise, that is what I'm telling. So I think a lot of things has been done in Eastern Ghats, and we know many things. Many things are clear to us now. Okay. Now, so this is the work of that gentleman who came from Australia, for doing the paleomagnetic studies. This we published in Lithos in 2013. So he determined the paleopole of those dikes. So, the paleopoles are used for knowing the supercontinental assemblies, how India was arranged in those supercontinental assemblies. So he has given 3-4 alternative arrangements. So B, C, D, where the perfect match can take place. I think Dr. Vijay Sahu is well acquainted with this type of work, how to make perfect matching between different continental fragments based on the paleopole. So we did this exercise for Eastern Ghats, taking the paleopole position on basis of these dikes, 1.4 billion year dikes. And we found that around 1.4 billion year, the Baltica was very close to India. The Dhorwar craton was very close to Baltica. Baltica, the northern part of Europe. So they were close to each other. So this is part of the Columbia Assembly. So India and Baltica were together. This is one of the findings. But as you know, this juxtaposition of different continents in making reconstruction of the supercontinents is very ambiguous, very ambiguous. Because my experience with this work, you just go to Lee paper on Columbia, Rodinia, you will find different configuration. India is close to northern China. The central India craton is going to the northern China craton. Because depending on their paleopole construction, they have found a different assembly. So like this, different viewpoints are there. So far as the supercontinental assembly is concerned, definitely it will be there because these are very older supercontinents. See, the Columbia supercontinent is 1.8 to 1.4 billion years, very old. So now while reconstructing them, several things are missed or several things are overlapped. As a result, different assembly comes up. So we have given that India was very close to Baltic. And somewhere you may find some other configuration. So one has to judge, how accurate your paleomagnetic pole construction is, paleomagnetic pole finding is done. Your accuracy of determining the paleomagnetic pole. It depends on that. Okay. So this 1.4 billionaire event is a Columbia supercontinent event. That has been proven. Now, one more interesting thing I'll just talk about. I told you in the first map I have shown that the west side of the Bastar Craton in Lucknow area, you have Khariar Basin. This the left part of this slide, I have shown the Khariar Basin. Khariar Basin, the central one is your myelonitic zone with Nepheline syenite intrusions, and eastern part is your Eastern Ghats Mobile Belt. Now, a very interesting outcrop we got near Bodan. Many of you might have seen also. I do not deny that this is my only finding. Or so there, you can see the picture. That platform sequence of rock has been tilted towards the Eastern Ghats. They are no more horizontal. They are some 30 to 40 degree angle. They have been tilted towards Eastern Ghats. So this tilting is because when and why it has happened, this tilting. But this tilting you will not find in all the outcrops. Particularly a single outcrop, I'll tell you, near Bodan, it is tilting towards Eastern Ghats. And the front of this tilted bed, is meeting that thrust. So we mapped this area. We collected structural data from this area. And what we observed, very interesting, that you see the below you have granite myelonite. Granite myelonite occurs up to 10-20 meter, That granite myelonite means shear. The myelonite which you see in the terrain boundary thrust, it is same granite myelonite. Over that, the shell is, half of the shell outcrop is also sheared. You can see minor folds. You can get myelonitic foliations in it. Now you go to the topmost quartzite, there is no deformation. There is so much closed space foliation in shell, so much closed space foliation in granite myelonite. It is not there in quartzite. But my observation may be a limited observation. I just cannot claim that it is absolutely perfect. That quartzite we saw in microscope, there is no deformation. The grains are absolutely fine, rounded grains are there. But the shell, you see the granulation cleavages are there. Some biotites are grown there. In microscope also, you will find those structures, granulation structures. And myelonite is anyway, it is a SC fabric, peripheroclast, all those things will be there. Now, if you see, this come to mind, why quartzite is not deformed? Is that the quartzite was deposited after the thrusting is complete? Thrusting, it affected the granite malonite, it affected the shell. After that, quartzite was deposited. This is what my interpretation. So when we published this paper, many people criticized also how it can happen. The quartzite is undeformed and these two parts are so much deformed. Your observation may not be correct. So as I told you, ours is a limited observation. Just one hill. We don't do regular mapping over kilometers after kilometers. So, but with a limited observation, what I interpreted, probably this quartzite is deposited after the thrust. So if that is the case, then this quartzite must be younger than 517 million years. Quartzite must be younger than 517 million. Because thrusting we are constraining as per the date of the Nephilim cyanide, that is 517 million years. So this quartzite is also less than 517 million. So that means this platform rocks, if this is correct, my interpretation is correct, then this platform rocks, the top part, more or less top part of the platform rocks, which is represented by this quartzite, is Neoproterozoic or Cambrian, you can say. Is Cambrian age. So these platform rocks, as you know, they form a very important geological unity in Indian Peninsula. So this Khariar Basin, south Kadapa Basin, then north you can see the Chhattisgarh Basin, further Vindhyan Basins. They are of similar type, similar age also. The maximum age of Kadapa Basin has been fixed 1.8 billion years. But top part, what is the youngest age of the top part of this platform rocks? There is still controversy. See, the Chhattisgarh Basin, there are publications which say it is 1 billion years. It is a Mesoproterozoic event. It has not gone to Cambrian. There are clear-cut publications. People have dated the rhyolite, the top rhyolite or tuff formations and said this is 1 billion years. Vindhyan also, there are publications, they say it is 1 billion years. But same Vindhyans, some people have got the trace fossils, Ediacarans, fossils in Vindhyans, and take the age of Vindhyans to Cambrian. So that top part of Vindhyans is still controversial. Similarly, Kadapa. Kadapa, we do not know the top part. So the bottom part is more or less fixed, 1.8 or 2 billion year age. But top part, there is controversy. It could be 1 billion year. If my interpretation goes, it could be Cambrian. Or the trace fossils from Vindhyans, if it is held correct, then that is also Cambrian. So this platform rocks or the Purana group of rocks, Purana basins, what we say. So these rocks could range, in the age right from 2 billion year to 400 or 500 million year. Very broad age range of rocks. So what does it imply? That means the Eastern Ghats sediments, which is produced khondalites, which is produced, say, other rocks within the Eastern Ghats, they must be contemporary with these Purana rocks. They must be contemporary. Maybe it has started at 1.8 billion year. Around that, the sedimentation has started. And it might have continued up to 500 billion year, 500 million year. And within that, when the sedimentation is going on in the basin, within that, 3 orogenic cycles has happened. 3 orogenic cycles. Start with the Nuna, Greenvillian, Pan-African. All of them affected them. All those orogenic cycles have been imprinted in the Eastern Ghats. The subduction producing granulite phases metamorphism, producing so much of migmatites. The central part of Eastern Ghats is full of migmatites. Charnockite metamorphism. All those things happen when the sedimentations are still going on in Eastern Ghats and the deformation is happening. This is also true for any orogenic belts, any orogenic belts. Now the Himalaya, you see, Himalaya, the entire Himalaya, till it comes up from the sea, most of the orogeny was over. When it came out of the sea, that is 10 million years before. But before that, most of the Himalayan orogeny was over. Within the sea, deposition was going on, and the orogenic cycle is also affected. So, like that, the Eastern Ghats, as per these evidences, probably started its life at 1.8, at 1.4, one orogenic cycle went. Then the sedimentation is still continuing. Greenvillian orogeny took place. Then it is still the sedimentation is continuing. Then 500 million year Pan-African orogeny also imprinted over it. Like so many supercontinental cycle happened, and the Eastern Ghat orogenic belt, the evidence of such polycyclic or polyepisodic orogenies. Now, this is very usual map, but there is something new, I have added. So the Eastern Ghat Mobile Belt is now being compared with Renner complex. Now, some of my work, now we are not doing any field work, but with some geophysics faculty member here, we are doing some geophysical correlations between the Eastern Ghats and the Antarctica part. Now, you see, you must be knowing these people also. The on-goal domain is the older domain, 1.8 say. Then Central Eastern Ghat part, maybe 1.4, 1.1, that is a younger domain. We are not going to Rengali, the Eastern Ghat part only. Now, Eastern Ghat part, we are taking it to Renner complex. Is it that all entire Eastern Ghat is Renner complex? Now, where is the on-goal domain will go? See, this part of Renner complex, there is another domain, Way Garden domain. So this Way Garden domain, we are now taking it to on-goal domain. And the eastern part of this EGMB, that and Way Garden, it is a continuous unit. On-goal, on-goal, then this Visakhapatnam side, this part, so they come to Way Garden part. The northern part of Eastern Ghats, western part, they come to Renner complex. So this type of curvature, this type of curvature in the Eastern Ghat combined Renner complex, that is a single mobile belt now. This type of curvature, a orogenic curvature or orogenic syntaxis. This orogenic syntaxis probably, made this structure, the salient structures or the recessive structures, the thrusting is so prominent in this northwestern part, is probably related to this orogenic or the syntaxial band. In the Eastern Ghat Mobile Belt and the Renner complex together, that syntaxial band which is there, that has produced this extra bulge, extra thrusting in the northwestern front. This is what we are now working on it. So papers have been communicated about this syntaxial band in the Eastern Ghat Mobile Belt. This syntaxial band which we are discussing, is between Eastern Ghat Mobile Belt and the Way Garden part. Together they form a folded like structure. So the folded like structures has pushed this northern part, developing so many salient structures or the nappe belts. That is what a recent work we are doing. So that is just under publication. We have not gone up to that. So this is all about the things. But again, I will come back to this map, I will come back to this map. Yeah, this map. So this map is, it gives a very well information about the Eastern Ghat orogeny. How it gives Western Ghat orogeny? Now you have Eastern Ghats, you have the shear zones, you have the dikes, you have this Purana group of rocks. Now the Eastern Ghats orogeny is now related with this dike intrusions. Now alkali nepheline cyanide intrusions in the Eastern Ghats is related to this dike intrusions. So this is related to that Columbia supercontinent assembly or Nuna orogeny. Now if you go further west, then the Harrier basin that shows a very young age. This young age probably reflects that Pan-African origin, which is manifested in the form of the second phase of nepheline cyanide dike intrusions. So this map, this first area is a very good evidence of polyphase or the multi-orogenic cycles in the Eastern Ghats Mobile Belts. And now with this, we are correlating with different assembly or different supercontinent assemblies based on our geophysics studies, based on our geochronology. That is what. So with this, I will conclude my talk. But I think I will enjoy, if we discuss something on this work.